Okay guys, today we're going to be going over the substitution method for solving systems of equations. It is assumed that you already know the graphing method for solving systems of equations, even though it is not needed for solving systems of equations. The first thing you must do when solving systems of equations using the substitution method is have either equation 1 or 2 solved for x or y. Either variable is fine. In the case that we have here, we already have equation number 1 solved for y. We will take what y is equal to and sub it into the y in equation 2. So y here is equal to 6x. We'll take this 6x and we will substitute it in for y in equation number 2, giving us 2x plus 3, and then we're taking the y out and we're going to put in a 6x is equal to negative 20. So now we will get rid of the parentheses by doing multiplication, collect our like terms, and then divide. So 2x plus 3 times 6x will be 18x is equal to negative 20. Combine our like terms here of 2x and 18x and get 20x is equal to negative 20. And then we'll divide by 20. And x will equal negative 1. Now that we have that negative 1, that equals x, we'll take it and substitute it back in equation number 1. And we'll get y is equal to 6 times, and then we'll plug back in our negative 1. And then we'll solve for y. So y would equal negative 6. Now to make an ordered pair out of that, our x coordinate will come first, negative 1, comma, negative 6. So this is the first type of system of equations that we'll look at with substitution, when they give us one of the equations already solved for x or y. The second type that we will look at is where they have both equations already solved for one variable. In example 2 here, we have both equations solved for x. So to use the substitution on that, I can pick either equation here. I can use this 2y plus 7, or I can use this y plus 4 and substitute in either or equations for x. So let's simply take this 2y plus 7 and substitute in for this x. When I do that, I'll get 2y plus 7 is equal to y plus 4. Then to solve for y, I'll have to move all my y's to one side, all my numbers to the other side, and then to divide if necessary. We'll subtract y from each side. 2y minus y is 1y, so I can just write down the y. And then plus 7 is equal to 4. And then we'll subtract 7 from each side. And y will equal negative 3. Now that I've solved for y, I'll take that y equals negative 3 and I can plug it in either equation to solve for x. So let's plug it into x is equal to 2y plus 7. And we'll get x is equal to 2 times negative 3 plus 7, which is x is equal to negative 6 plus 7. So x is equal to 1. Now that I have both solutions, I can make my ordered pair 1, comma, negative 3. And that is our second example, the case where we have both equations solved for the exact same variable. The third example we're going to look at is where neither equation is solved for a variable at all. So we're going to need to first solve one of these equations for x or y. If I look at the first equation, I'm going to have to do some subtraction or addition and then some division to solve for either variable. But if I look at the second equation here, I should see quickly that I can easily solve the second equation for the variable x. I can do that by simply subtracting 6y from both sides. And x would equal negative 6y plus 18. Now that I have that, I can take and plug that negative 6y plus 18 in for x into the first equation. So I'll take that and we'll stick it right here. So I'll have 2 parentheses negative 6y plus 18 close our parentheses minus 3y is equal to negative 24. Now to do this we'll have to use the distributive property, meaning we'll have to multiply both numbers inside the parentheses by this 2, and we'll get negative 12y plus 36 minus 3y is equal to negative 24. We'll collect like terms in here. I have a negative 12y and a negative 3y, which will give me negative 15y plus 36 is equal to negative 24. I'll move my numbers to the right now since my one variable is on the left. Minus 36 from both sides. Negative 15y will then equal negative 60. Divide by negative 15. And y will equal 4. So now that I got y equals 4, I'll take it and let's substitute it back into the equation that I solved for x. That will help us to easily find x. We could plug it into either this equation here or this one here, but then we're going to have to move a few things around to solve for x. In this case here, we can just substitute in for y, multiply, add, and then we should be finished. So we'll have x is equal to negative 6 times our 4 plus 18. So x will equal negative 24 plus 18. So x is equal to negative 6. Which means I can now write my ordered pair. Negative 6, comma, 4. Okay, I hope this helps y'all with the substitution method for solving systems of equations. If you have any questions, you can email me or leave comments.